Module 10, Lesson 2 covers dot plots and histograms. According to the textbook, this is a single-day lesson, and considering they only have 8 resources in it, that's probably going to be pretty accurate. One of Colorado's biggest tourist attractions is the Rocky Mountains National Park. The Rocky Mountains run through most of the western part of the state. Many peak well over 14,000 feet. Hikers refer to the peaks as over this threshold as 14ers, and my oldest son has climbed 2 or 3 of those by now. According to the Colorado Geological Society, there are 58 14ers in the state of Colorado, the most in any state in the U.S., so he has a lot left to go if he plans on summiting all of them. One way to show the height of the 58 peaks would be to list the height of each peak. Another way would be to show the heights on a graph. How do you think you could show the heights of the 14ers graphically? These are some of the things we're going to be talking about in today's lesson. Constructing dot plots. One way to represent data is to construct a dot plot, and it says right here, a dot plot is a visual display of the distribution of data values where the data values are shown as a dot above the number line. I have also heard of these called as a line plot in another textbook I used to use, and instead of using dots, they would use X's over each data value on the line plot. Either way is perfectly good, and either way is a perfectly good name for it. The number of wins in recent years, several football teams are listed here. Look at all those pretty numbers, and the data is shown on the dot plot. It's a good visual display that helps to organize data and show possible patterns. So for example, you can see that there was 4 teams that had 5 wins that year. There was 2 teams that had 12 wins that year, and there was 5 teams that only had 1 win that year. These are some of the easy things that you can see and understand when looking at a dot plot or a line plot. In example number 1, Jasmine is surveying students in her class using the question, how many pets do you own? I think we saw that same question yesterday. The results are shown in the table below. So here you've got a list of all the different students and how many pets each one of them say. And they want us to construct a dot plot of the data and then summarize the results we get from it. So let's see, anything else down there? Nope, don't see anything we need there. So what do we know? We know that we have numbers 0 through 4. The fewest number of pets somebody has is 0. The most pets somebody has is 4. My family calls that weak. We have 8. So the line needs to go from 0 to 4, and because the least data value is 0 and the greatest data value is 4. So we're going to drag the values to label the number line. So I guess we're going to have a 0, a 1, a 2, a 3, and a 4. So right there, our number line is no, there we go, just had to wiggle that one. Our number line has been made. And next thing we're going to have to do is we need to take and list how many pets there are in each category above it. So let's scroll down just a little bit, and I'm going to be working vertically here through these. So I'm going to start off, I have a 3, I have a 2, I have another 2, I have a 1, I have another 3 and another 1. That's my first column. In my second column, I have a 0, a 1, another 0, a 2, a 3, and a 4. In the next column, I have a 0, a 1, another 1, another 3, and 2 more 2s. In the last column, we have a 1, we have a 2, we have another 2, we have a 4, we have a 0, and we have another 2. So, what can we say about this information? Well, for starters, more students have 2 pets than any other category. That's the thing that jumps out to me. And that the fewest number of students that own pets, the number of pets would be 4, because you have only 2 students own 4 pets, and things of that nature. So we're going to check our answer. That answer checks. Let's keep it going. Next, we want to take and summarize our information. So in summarizing the information, first thing we need to find the sample size of how many students responded to the questions. And I'm going to do it this way. I'm going to look at my table, which is 1, 2, 3, 4, 5, 6 by 4. So that means I had 24 students responded to the question. That checks. Next question we have is, what's the greatest number of pets a student owns? That's going to be 4. And what number of pets are students most likely to own? That is going to be either a 1 or a 2, I guess, because those are the two most common numbers that took place. So both of those check. And then finally it says here, so the number of total of 24 students responded to the survey, which is going to be your sample size, fancy vocab term, sample size there. Students are more likely to own 1 or 2 pets than they are to own 3 or 4 pets, and no student owned more than 4 pets. Right there, we have taken and looked at all the data we have and summarized what the data actually means. Now it's going to be your turn. Work extra example 1, pause the video while you do it. How'd it go for you? You can see right here it's the dot plot that I created, and you can see that 2 was the most number of musicals that the people attended in the group. Go ahead and check that. That answer checked. And from here we can say there were blank members of the theater club that responded to the sample size. This is going to be, there was 3 rows of 5, so that's going to become 15 members of the theater club that responded, and that's going to be your sample size. The greatest number of musicals attended was going to be 5, because one person just really loves musicals. They went to 5 of them. The least number was 0. That's a category I would have been in. And then the most students have attended 2, because 2 was the most common number of musicals found or checked. All that checks, and we're good. Easy math. Anybody can do this stuff. From here, we're going to learn how to construct a histogram. A histogram is a very scary term, but all it is a bar graph that involves the frequency of occurrences. And right here you get the definition. The data from a frequency table can be displayed as a histogram, which is a type of bar graph used to display numerical data that has been organized into intervals. So right here you can see you've got a bar graph displaying numerical data that has been organized into intervals of, looks like about 50 right here, $24.99 on each one of those. This allows you to see the frequency distribution of the data or the quantity of the data that are in each interval. When constructing a histogram, it is important that the intervals are equal. Okay, you can't have 0 to 50 in one and then 50 to 500 in the next one. So that you can make accurate observations about the data based on the height of the bars. The interval should have no gaps so that the entire range of data can be represented. And we're going to select some markers here to learn about the histogram. So this one right here tells us there's no space between equally sized bars, okay? So we got the bars right here, they're right next to each other, there's no space between them. They're also going to be equally sized, meaning they're the same width. Next thing is that all the intervals are equal, so you can analyze the bar heights accurately. So every one has the same intervals horizontally and the same intervals vertically. And then finally, intervals with a frequency of 0 have a 0 bar height. So this is not a gap or a space between the bars. This represents a data value where there was no data that fell into that category. Now example 2 has us actually constructing a histogram. A park ranger at a state park was asked a statistical question: how many daily visitors attended the park each day for 20 days? The table shows the results. So here you got the results of their answers of each day. There were 108 one day, 165 visitors the next day, and so on. And they want us to take and construct a histogram to represent that data. So from here, step 1, make a table. And then in that table, how many are going to fall into each one of these categories? The grouping of their table is going to be 50, so from 100 to 49, 150 to 99, and so on. So the 100 to 149, that's going to be 2 days that occurred. And then the next one, 150 to 99, that's going to be 1, 2, 3, 4, 5, 6, 7 days that occurred. 200 to 249, that's going to be 1, 2, 3, 4, 5, 6, 7, 8. That's, I think, going to be our mode, the one that occurs the most often. 250 to 299, that's going to end up being 1, and yep, just 1 there. And then our 300 to 349, that's going to become a 1, I think. And then 350 to 399, I believe that's also going to be a 1. Check our answers. All those check. Very good. And from here, we're going to need to graph that on our histogram, which is our fancy bar graph that compares statistical data. Now, when you construct a bar graph, we need to first draw the axis that we have. So we have the vertical axis, which is going to be the frequency, and the number of days that this occurred, and the horizontal axis is going to be the category for the number of visitors. Now our data only goes from 100 through 399 because that's the table categories that are listed here. And so you have a little break right here on the horizontal axis of your bar graph because from 0 to 100, we just don't care. There was no days that had 0 to 100 visitors attend. Next thing we need to do to draw it is for each interval, we're going to graph the height that is indicated by the frequency table. So let me zoom out a little bit here. So the 0 to 100, that's going to become 2. And then the next one is going to go all the way up to 7. And then the next one is going to be 8. And then the next 3 are going to be 1 each. Check the answer, and that checks. And that's how you create a bar graph or a histogram of the statistical data. Now it's going to be your turn to pause the video and create your own bar graph based off the data that we have right here. Notice they've already set your scales for you. You're going to be going from 60 to 69, 70 to 79, 80 to 89, and so on, making it a 10-point difference on each one of them. Now the first thing I need to do is figure out how many fall into each category, and the way I'm going to do this is I'm just going to be ticking them off and making a little tally chart here. So that one's going to be the 70 to 70, that one's going to be in that one. I have an 80, I have an 86, I had a 92, I have a 98, I have an 88 right here, a 76, a 79, an 82, a 91, an 83, make that a 5 count, a 91, make that a 5, okay, 90, make that a 5 count, a 76, an 81, a 94, a 96, a 92, a 72, 5 count, an 83, an 85, a 65, a 91, a 92, another 5 count, a 68, an 86, an 89, another 5 count, and a 97. So what are my numbers going to be? I'm going to have 2, 5, 10, and 11. Jump back over to my chart right here, and this one there was 2, this one there was 5. Oh, I went too far. No, I didn't. Yep. 2, yep, that should be right, 5. This one here ended up becoming 10. Go all the way up to the 10 mark, which I believe is right here. And this one here ended up going all the way up to the 11 mark. And when we check our answers, it should all check. That's all there is to making one of these This is, of course, what you're going to be doing in your homework. I would encourage you to use those tally marks on the big charts to count up your number of occurrences for each bar in your bar graph. And with that, get started on your homework. I'll see you in class tomorrow.